Welcome back to Physics Forum. So in the previous lecture of center of mass, we have already seen how to calculate center of mass of continuous body having linear mass density such as semicircular ring or uniform linear rod. In this particular video, we are going to deal with calculation of center of mass of continuous body having surface mass density such as semicircular disc, hemi-hollow sphere. So let's see one by one all these examples. So let's begin with center of mass of semicircular disc. Of course, uniform semicircular disc, right? So first we define our axis. So this is origin and this is x-axis, this is y-axis. So again we can expect that center of mass will be lying along y-axis from symmetry, because had it been complete, its center of mass would have been exactly at its geometrical center. But if you remove the half part from here, it will shift along y-axis. So center of mass will be lying along y-axis. Now we define our surface mass density. So sigma will be how much? This is m by area. So this is m by pi r square by 2. As this is semicircular disc, so this area would be pi r square by 2. Now from definition, if we write, now how to first we see how to take element in this particular situation. So we have already calculated center of mass of semicircular ring. So with the help of semicircular ring, we will calculate center of mass of semicircular disc. So we know that in case of semicircular ring, the center of mass was lying at a distance of 2r by pi from origin. So we take element here as a ring at a distance of small r from origin, and thickness of this elemental ring is dr. So mass of this elemental ring, so this is my elemental ring. So mass of this elemental ring will be sigma into differential area of this elemental ring. So this would be pi r into dr. Now how do we have written this pi r into dr? So if we straighten this semicircular part, the length of this semicircular part would be pi r, right? The length of this semicircular part, that would be pi r, and this thickness dr, that would be dr. So we can write down simply area of this elemental ring pi r into dr, and we will simply multiply it with sigma, then we will get differential mass. Now coming to the definition of center of mass, so YCM will be Y center of mass of differential mass into dm by dm. Now if we take out this elemental ring outside of this, so this elemental ring is at a distance of small r, right? So center of mass of this elemental ring will be at a distance of 2r by pi from origin. So center of mass of this differential mass is lying at a distance of 2r by pi from origin. So this is what we are going to write, 2r by pi, and dm will be written as sigma into pi r into dr, and by integral of entire dm, that is m. Now taking out all the constant terms together, so this comes to be 2 sigma by m r square dr. Now how to take integration limit? The first element will be formed at a distance of, at a radius of r is equal to 0. So the first radius of first elemental ring will be 0, and the radius of the last elemental ring will be formed over here. So radius of that elemental ring will be capital R. So the integration limit will be between 0 to capital R. So 2 by m, putting the value of sigma from here, So this is basically, this is how much? 2m by pi r square, right? So 2m by pi r square into r cube by 3. So this comes to be 4r by 3 pi. So in case of semicircular ring, this was 2r by pi, and in case of semicircular disc, this is 4r by 3 pi. So center of mass of this semicircular disc will be lying at a distance of 4r by 3 pi from origin. Right. Now let's see center of mass of uniform hemi-holosphere. Now again, as this is hemi-holosphere, so there is no mass inside the body, right? All the masses are present at the surface of the body. So again we are going to take surface mass density. So let's first define sigma is equal to m by a. So m by 2 pi r square. As we know that the surface area of entire sphere is 4 pi r square. So for hemi-holosphere, this would be 2 pi r square. And again, from symmetry, the center of mass will be lying somewhere here, right, along y-axis. Now, how to take element in this particular case? So what we do, we take an elemental ring at an angle theta. We have taken angular element over here as this mass is distributed over the angular profile of the body. So this elemental ring is making an angle theta over here, and this thickness is making an angle of d theta at O. So this dl will be again rd theta. We have already seen such type of examples in the previous lecture. So this dl will be rd theta, and radius of this circle, this is theta, so this is also theta, and this is r, so this is r cos theta, right? So differential mass, that will be sigma into dA and sigma into the circumference of this ring, that will be 2 pi r cos theta into thickness dl. So this comes to be sigma 2 pi r cos theta into rd theta, right? Now again, from definition of center of mass, so ycm is ycm of dm into dm by dm. Now center of mass of this differential element, this elemental ring, as this is a complete ring, so its center of mass will be lying at its geometrical center, that is over here, which is at a distance of r sine theta from O, right? So we can write down ycm to be, this is r sine theta, and putting the value of dm from here. So this is sigma 2 pi r cos theta into r d theta, right, divided by total mass. Now again, taking out all constant terms from the integration, so this comes to be sigma pi r cube by m and 2 sine theta cos theta d theta, and this expression can be written as sine 2 theta, right? So sigma pi r cube by m sine 2 theta d theta. Again, how to take integration limit? So the first element will be formed here and the last element will be formed here. So this would be integrable between 0 to pi by 2. Now integration of this one will be minus cos 2 theta by 2, 0 to pi by 2. Putting all the values, so sigma is m by 2 pi r square into pi r cube by m, and this would come to be 1 plus 1 by 2. This is 1, so the final answer is r by 2. So you might say that the center of mass of this hollow sphere will be lying at a distance of r by 2 from its base, right? So in case of semicircular disc, it was 4r by 3 pi, and in case of hemi-hollow sphere, this is r by 2 from its base. So I hope you like my video. If you like my video, subscribe to my channel and hit the bell icon. Thank you so much. Thank you for watching.